Hello and welcome to another problem, 704, binary search. So we're given an array of integers nums, which is sorted in ascending order, and an integer target, and you want to write a method to search target in nums. If target exists, then return its index, otherwise return -1. That's easy enough, but however the caveat is you have to write an algorithm with O of log n runtime complexity. So a way to do this using O of n would be just to loop through every single item in the array and return the index once you reach the final target value. However, that's not the best time efficiency because it's O of n. And to do it during log n, to do it with the log n runtime complexity, we can use something called binary search, which is what the problem statement is. So binary search works pretty much by you have the target. You can compare what the middle of the array is with the target and figure out whether or not it's less than or equal to, like less than, equal to, or greater than the value. So to best illustrate with this, I can do an example. So we have 9. We first check what the middle of the array is here. Is for here. It's 3. We check to see, oh, okay, 3 is less than 9. Therefore, all of these values, because it's sorted in ascending order, all of these values do not matter anymore because it's all less than. So all we need to do is check this one, this remainder of the array. We can figure out what the middle is from there. It's 9, and we can check to see whether or not it's equal, less than, or greater. It's equal. We return that as the index, and there you have it. So this way is a lot faster because you're only really having to sort it. You're cutting down half of the elements every single iteration through, as opposed to having to iterate through each one individually. So yeah, and the way to implement this would be to have a pointer to the left and the right, starting at the beginning and the end of the array, and every single time, you have to try to figure out what the middle is, and let's say you want to rule out all these values. You just shift the left pointer to equal to the middle. Middle -1 because it's 0 indexed, and then yeah, just then you keep sorting it from there. Same thing with the right side. You keep shifting it, so on and so forth. So just to code an implementation of this, we have the left and the right, which is equal to 0, and the length of nums -1, and then we can check while left is less than or equal to the right. We want to figure out what the mid is. And what we can do, one way of doing so would be L plus R dividing it by 2 in order to get what the middle of the array is. However, this has some issues because if these values are really, really large, nearing the constraint for the maximum for the maximum integer for a value it may have the ability to overflow and give off the incorrect answer. So a way to stop this from happening, if we add those two numbers, they're really large and they end up going over. What to stop them happening is by using this instead. We have L plus R minus L divided by 2. This way, there's no possible way in which the two numbers can be added together for it to have it overflow, and this achieves the same purpose of finding the middle of the array. So once we have that out of the way, we want to check if nums m is greater than the target. Then we want to set the right to equal m -1. Otherwise, if it's less than the target, then we want to set m equals m plus 1. Else you want to return m because you find the final value. And then it says here you want to return -1 if it's not the correct, if there's no final results. We want to do that. Let's run through this. With the example. So let's see, our target is our target's 2, right? So we have a pointer at the beginning and the end. You figure out what the middle is over here. Is it greater? Let's see. Is the value at that middle point greater than the target? What is it? It is greater than the target because the target is 2. So what it does is it shifts the right to equal m -1, which means this right pointer will go all the way here. It'll only be checking these values, and then it'll keep going on, doing it in half until eventually you realize that number doesn't exist, because yeah, the pointers end up coinciding. So we'll go ahead and run this. If we do that. Oh, what am I doing? Whoops. That needs to be left. Okay, yeah. So there you have it. O over log n, time complexity, space complexity is... Wait, no, sorry. O over n time complexity and O over 1 space complexity. So, yeah, thanks for watching.